construction industry requires more resources than ever. Globally, the sector is responsible for 38% of all CO2 emissions and produces 84% of all waste in Switzerland. That's over half a ton of construction waste per second. The canton of Zurich has an important role as it is responsible for a major part of building demolitions in Switzerland, and the so-called replacement for inner city densification is still the most popular option when dealing with existing building stock. To reach our collective carbon and energy goals, we need to stop the unquestioning demolition of buildings and reduce the massive waste of resources and energy. The necessity to demolish a building should be questioned in the first place. If that's not an option, the next necessary step is reuse. Carefully deconstructing existing buildings and using the components to create a new project. Until now, the process of reuse is time-consuming, labor-intensive, and faces regulatory challenges. With new technologies at our disposal, we can speed up the process. During the deconstruction and reuse of the Huber pavilions at ETHZ Zurich, we tested these methods. Scanning technologies are one of these important tools. They can be used to digitize entire buildings, components, and materials. Some older buildings have missing or only incomplete information available. To increase efficiency for repairing, adapting, or reusing buildings and components, scans can deliver accurate visualizations and measurements based on point clouds. Simply explained, laser scanning measures the distance from the scanner to a point by counting how long it takes the reflection of the laser to come back. To generate a 3D point cloud, the scanner rotates and then repeats the procedure in every direction. To prevent hidden spots, so-called occlusions, the scanner needs to be moved around the scene and connect the different scans. An issue for scanners are reflective surfaces, since they don't reflect the laser back to the scanner. Portable scanners are an easy and affordable way to scan moderately sized structures and indoor environments. The device tracks its location using gyroscopes and cameras, so one can move around and also access complex locations due to its small form factor. Similar to the handheld scanner, the LiDAR in newer phones can be used to perform quick scans of objects if no other tool is available. Using it in combination with the cameras in the phone can add some color and texture to the scan. For large construction sites, the way to go are stationary laser scanners. These achieve millimeter accuracy over large distances. To automate the process even further, these scanners can be mounted on robots or drones who can then autonomously move around the construction site, thereby accessing difficult areas and reducing labor costs. Photogrammetry is the process of stitching together multiple photos from different viewpoints to estimate a 3D model. Specifically, the software tries to find referential points in the images and connect them. Photogrammetry allows for colored 3D models, but is not as accurate as scanning and requires a lot of post-processing. Nowadays, cameras are built into everything, so we can quickly take photos and videos with our smartphone or use small drones to generate 3D models using photogrammetry. For the planning of larger projects and general information about the building environment, Google Earth offers global models generated using photogrammetry from cars and satellites. Additionally, giant open-source point clouds of Switzerland were generated by drone scanning. Scanning can first create a point cloud and automatically generate a BIM model from the collected data, thereby facilitating the planning of deconstruction and reuse. Progress tracking during the assembly and disassembly of a structure can also be automated to a large degree by using scanners. Especially important for reuse is the analysis of reused materials. These are often non-standardized, can have varying degrees of contamination from previous life cycles. By creating 3D models of the building stock, the materials can be entered into a database. In the past years, scanning has gotten cheaper, lighter, faster, and more automated. Therefore, we will see it in more construction sites, like the construction of Circle B.